Hello, everyone. Let me present the speakers of the next talk in our afternoon session. Boyan Rusev, Senior Engineering Manager from Yara, and Theo Harkenbusch and Dr. Konstantin Pfrang, both Senior Consultants from TNG. As an enthusiast for digitizing agriculture, Boyan holds a master's degree from the Technical University of Varna in Bulgaria and has over 10 years of experience in software development and technical leadership. He leads technical decisions and architecture for Yara Plus, Yara's newest software product for modern agriculture. Theo discovered software through gaming in his years in high school. Following that, he received his master's degree in computer science from the University of Paderborn. And in 2022, he joined TNG, where he impresses clients with his technical expertise and keen eye for good design. And I can vouch for that. Konstantin has a background in very high energy gamma ray astronomy, holding a PhD in physics, where he developed AI-driven data analysis methods before joining TNG. He's now a full-stack developer focusing on the adaptable and scalable architecture for microfrontends. And with this, I will hand over to our presenters for their talk titled From Field to Cloud, to learn how Yara Farming Solutions Europe uses cloud technologies to transform farming in the digital age.
Thank you, Marco, and thank you, everyone. Good afternoon, and thanks for joining us today. I'm Boyan, as Marco said, and I'm here with my colleagues to present you our newest application. As you can see, it's called From Field to Cloud. What does it mean? It means that we want to bring the traditional farming, which you all know, into the digital space, and we want to basically tightly couple it with the newest technologies which are out there in 2025, with the data tools and all the capabilities in order to make the whole farming solutions more efficient. Just before we start to explain how we have built the Yara Plus solution, I would like to quickly explain about the company that I'm working for, Yara. It's mostly famous for selling mineral fertilizers, one of the biggest out there. We are quite old as a company, more than a century probably, like 118 years. And we are operating in more than 60 countries across the world. Besides the selling mineral fertilizers, we are quite famous for our zero emissions initiatives for the past few years, including the first zero emission vessel, quite autonomous. It's called Yara Birkeland. You can Google it if you want to. And something else probably is the AdBlue, if you're familiar with that. Yara is one of the biggest producer of AdBlue in the world, which is basically, again, reduces the emissions in the diesel engines. Among these initiatives, we are also in the digital space from a few years. To be honest, like 2016 was our first attempt to join the digital space. And that's not from 2016. That's quite new. But we made a few mistakes. We started with the different approaches. It took us like a few years to find the right track. But we wanted to not repeat our mistakes. And that's why in 2023, we decided to build our new platform. It's called Yara Plus. And as you can see, it's all in one. What does all in one means? Well, how we started it. We decided to go and take all the requirements from all the markets, all the countries across Europe. And funny enough, we understood that the farming is not the same in all countries in Europe. It sounds ridiculous, at least for me as well, probably for you too also, but that's life. So farming is different, and we need to adapt. We need to adapt our digital solution into each country, each market, and that's why Yara Plus is here right now. But also, we understood that we don't want to target only the farmers. We wanted to target everyone around the farmers. Distributors, farm contractors, agronomists, everyone around the farmers. So that's why we wanted to basically connect them all into one application, and we wanted to build it as scalable as possible because we believed in this, that's the future. So let's go to the demo because I wanted to show you how it looks like rather than speak too much. Okay. Not exactly, I guess.
I think you just have to move it to the other screen then.
No, this is completely mirrored.
Yeah, as always, technical issues.
I don't know.
Okay, yeah, thanks. Yeah, so that's the entry point for Yara Plus, and as you can see, there is multiple modules on the front screen. These are different modules which represent different functionalities for each of our customers. Again, as I said, it's not only about the farmers, it's also about the distributors, farm contractors, and everyone around them. So we can see modules which are tightly coupled for grassland crops, arable crops, requesting a quote, all these things which are making the app quite attractive for all the parties, not only for the farmers. I won't basically spend the time to explain all these modules because in the end the topic is for the how we have built it, but I'm going to quickly show you just the most, let's say, nicer module, which is the ad farm. So you were wondering how the digital space is connected to the farming, and yeah, that's a normal field somewhere around Munich. Don't know exactly where, but somewhere around here. And you can see on the screen that here, based on satellites, we are able to see, okay, on your field you have less growth here, but more in the center, and so on and so on. And what does this help us? It helps us that, okay, not us, but the farmers, is that you don't need to apply the same amount of fertilizers on the whole field, because that's a huge one. We need to be efficient. We need to basically apply a proper amount of fertilizers on each part of the field. So this helps us to be efficient and be more precise on applying the actual fertilizer. And here we can see a variable rate map, which is saying, okay, now please you want to apply Yara Bella sulfan, and that's your field. And based on the agenda here, we can see on the dark blue, you need to apply much more fertilizer from the Yara Bella sulfan, rather than here on the center where you see the yellow boxes. So this means that here, the field is quite better than the other parts of the field. So how this helps, basically when we generate this, it's based on satellite images, sensors, and so on. Also Yara knowledge behind the scenes. There is a agronomist who calculated the whole thing, and they are recommending this to the farmers. From there, you can basically export it directly to either simple shape files, or you can directly go to your tractor. So from this app, you can go directly to John Deere tractor, and then the tractor can basically even drive alone and apply the product by himself based on this heat map. And yeah, that's enough for the demo. There is different modules for different, not all, this is only arable crops, but there is also grassland and so on. And now let's see, okay, this time it works. How we have built it. Okay, that's the interesting part. As I said, we were not starting 2 years ago in 2023. We basically started 2016. And again, as I said, we did a few mistakes, and we didn't want to repeat them from technical point of view, but from others as well. So we get the requirements, everything was perfect, but now how we should start. And together with our FTEs and our colleagues from TNG, we said, okay, let's sit and think about what we need to achieve, how to achieve it in the best possible option. And that's how the microservices on Yara Plus side came alive. So we decided to go, okay, let's go with microservices because we wanted to go big. There is a scalability. That application is going to be for not only for a few people, but the idea is to be for thousands of users. And yeah, we decided to go with microservices. The idea was to be scalable, maintainable, and easy to deploy from the whole team. The team is not that small, and basically we wanted to separate each part for a specific team. As you know, a typical approach, each microservice has its own database, it's quite decoupled, so everything was perfect. Okay, but when you say microservices, what is next? It's not just let's go microservices and that's it. There is a few approaches which we could take, and as you saw in the demo, there is multiple modules in the application. There is approach of taking one service per microfrontend, not bad, probably a few more things to duplicate, but yeah, we said, let's try something better. Then we went to the one service per domain, which made more sense for us. But also there is a little bit risk of a misalignment with the front end. And then we were thinking for quite a long time, and we said, okay, let's go with something in between. something called Hybrid Plus. And you're going to ask yourself what means Hybrid Plus. Hybrid between these two, plus something on top from us. What this means? So we took the one service per microfrontend, which was, now if you ask me, it's probably a mistake. But that was done because of the deadlines. And then all the other architecture was per domain. But we didn't want to repeat the same mistake because this could quickly scale up and become a mess to maintain. Because imagine we have 20 plus services and they are quite granular. So there is 1, 2, 3 tables maximum, and then there is not so many people to maintain these. So we didn't want to end up in that situation again, and that's why we decided to go with the plus approach. So we built something similar to monolith service, and we put everything centrally there, which is like the farms, the users, distributors, everything which is quite central for the application. And then we built everything, all the other domain services around it. So how this looks like, it's something similar to this. So there is a microservices dash monolith approach, which is the core service where we have everything central, everything which is quite important for us, and that's it. And everything around it is the other domains, which you can see, for example, everything which is commercial, request for quote, request products, big bag requests, recycling, and so on. So all of these things have their own domain services. Also, the communication between other partners. Let's be honest, in 2023, there were so many other farming-facing solutions that we didn't want to compete with them, but we wanted to actually integrate with them. So similar with that was the John Deere integration. So everything which is coming from external partners, it's in this external partner service, for example. So we decided to go with that approach in order to be as easy to maintain as possible, but also to scale if we need it. Yeah, what we have learned, that's an interesting one. It's impossible to avoid duplication, let's be honest. We did our best. We have so many libraries and shared code and so on, but in the end, there is like, these are not all the services, there are more. These are the most important ones. There are more services, and then basically we are duplicating. We're trying so bad, and it's basically impossible. And then what is the nightmare, at least for me, and probably for some of the TNG colleagues as well, when there is a new feature, where we should put this table? Where should we? Shall we create a new service? Shall we go with existing one? So there is always a debate, and we are, okay, I would say arguing, but it's a nice and healthy arguing. So yeah, and something which I definitely would like to advertise is please correct your mistakes with the microservices as early as possible. Because with these wrong, for example, wrong placement of tables and so on, when you see the issue, try to fix it ASAP. Otherwise, the issue becomes bigger and bigger, and the title coupling is awful. It's basically, yeah, you don't want to go with that. And then finally, yeah, would you go with this architecture again? I was thinking about this for a couple of weeks since I was basically invited for the talk, and I was like 50-50 till then, till yesterday. But yeah, I was flying to Munich, and I was like, am I really gonna go with the same approach, or yes or no? And honestly, looking back to it after like 2.5 years, now I'm not 50-50. And I'm mostly 60-40 to basically not take the same approach. Yeah, it's easy to say now, but yeah, it is. So we need to admit our mistakes. We won't rewrite it, Luca, so no worries. We want to keep the microservices. But yeah, I would just say, think a little bit more just before we go microservice. I know that they're viral and everything is like, wow. But back then, we thought that this is extremely scalable, flexible, and so on. We basically thought super big. We don't need to. We can easily scale from a monolith to the microservices. Speaking about mistakes, something which I would never say it's a mistake, and that's the GraphQL. What is GraphQL? I don't know if you're familiar. It's not something extremely new. It's something which is alive from more than a decade. I think Facebook invented it back then. That's again HTTP request, but you basically ask for something and you receive the only thing that you have requested. You don't get nothing more, nothing less. You basically, you want 2 fields, that's it. You want some kind of a connection to the, let's say, the commercial example of the book and the author. You get both of them in one single request. Basically, with our module approach of the front end, which Konstantin is going to explain later, you're going to see that each part of the application needs different things. Yes, they live in the same table and so on, but you want different things, and that's how the GraphQL is really helping us. We are using the Apollo Federation, which is also awesome. I love it. And how it works, basically each microservice here, it just represents as a subgraph, and everything is pushed to a gateway, which is our communication endpoint. So our clients, the web application and the mobile one, they all connect to the gateway, or you also cannot see it called as a supergraph, and you query everything from it. Everything is connected, and if you make a request, the API gateway, it's smart enough to generate a query pawn, and this query pawn is going to take everything from each service and provide it to you as fast as possible. And in order to explain how everything is basically working on the front end and how we're calling the gateway, I'm going to pass the word to Konstantin, and yeah, thanks.
Thank you, Boyan. Now, as Boyan already mentioned, I would like to shift your attention to front end. Let me actually see. That's the right button. Perfect. During the demo, you have seen that Yara Plus is this product suite that integrates different solutions into it that really have different needs. So inside of Yara Plus, we have AdFarm, which is our solution for arable farming. We have commercial features that live under a shop application. We have a QuestN, which is really for grassland fields, all kind of different stuff. In total, at the moment, we have 8 solutions integrated, potentially growing more. And when we were first thinking about how to build this, we actually had a similar thought like we also had in the backend. Why don't we go modular? Like splitting our code by domain and trying to achieve independency, and particularly also like in the way how we're deploying these things, not wanting to couple them together. And this is what we're calling microfrontends. This technique of microfrontends particularly has gained a lot of traction recently, like in the last couple of years with Module Federation, which is kind of like allowing to share JavaScript modules on runtime, which means you can separate your code during the development, and later on still have like this nicely integration of like one application that is running in the browser. This feature was initially introduced in 2019 as a Webpack feature, and since then has gained a lot of attention, and particularly in the last year, also with version 2.0 being released, made a huge step forward, because like now there was a decoupling from the bundler, so from Webpack, by introducing a runtime API. And then just in general, it was a huge step forward in sense of like scalability of microfrontends with Module Federation. So really quite exciting topic on itself. In Yara Plus, however, we don't use Webpack as a bundler. Instead, we decided to use Vite. Vite was a very smart choice for us because compared to Webpack, it's rather simple in order to configure it. It's flexible, and particularly, which is very important for us, it's fast. Because our development process is simply faster, we can also move ahead really more in a larger speed, which really is beneficial for us as entire project. However, back in 2023, when we started, Module Federation didn't have an official plugin for Vite back then. It was more in the Webpack space. Instead, we started to rely on this Vite plugin federation, which introduced the same concept of Module Federation also for Vite back then already, which overall works quite fine, has a couple of initial challenges for us, but we are still running it since almost 3 years now, and managed to do most things we wanted. Let's dive into how this actually works, like in real life. I already mentioned that the objective of the microfrontends is to split our code. And having our individual solutions that I just discussed, it makes sense to split our code by solution. So we have one microfrontend that is AdFarm, one for shop, and our 6 other solutions. All are in their own GitHub repository. they have their own testing and build pipeline where we're now using Vite. And at the end, we have the ready bundle. At this stage, all of them are completely independent. AdFarm doesn't know that the shop even exists at this point, and vice versa. On top of this now, we also have one more application, which we're calling the suite. The suite is literally the product suite that later has the purpose to integrate the different solutions into one running application. This is why we're also calling it a host application, since it's hosting the microfrontends. It as well is in its own GitHub repository, built completely independently, and we have its own bundle. It also doesn't know at this point yet in the development that the microfrontend exists, so it's still independent. The magic kind of starts when now the user goes to the browser. So as soon as he visits our homepage, app.yaraplus.com, the first thing that is going to be loaded always is the suite, because the suite has to be present and later on hosts the other applications. Now, from here, we have mounted the microfrontends under different URLs. As soon as one of as soon as the user goes to one of those URLs, for example, as /adfarm, these corresponding bundles that we need will be loaded dynamically at runtime. So really only as soon as the suite requests them, which is already pretty cool. And it works under the hood in a way that the micro front end hosts under a stable URL this remote entry, which has kind of you can understand this remote entry as a kind of like a mapping of which component that is exposed correspond to which chunk in the bundle. And then the suite knows exactly what kind of which code it needs to load and integrate in order to show this dynamic component. Also, it does some has a matching of the dependencies that it requires, so to make sure that all the dependencies that this microfrontend needs are also there in the shared space. Overall, this concept works quite beautifully. At runtime, we have this one running integrated application, but during development, we're independent. We don't have any coupling, which is pretty cool at itself. However, compared to traditional monolithic setups, it's also more complex. And complexity always comes with challenges. And in the following, I would like to go through a couple of challenges that we've particularly been facing and also how we approach them. The first one I would like to draw your attention to are shared dependencies and bundle sizes. Shared dependencies is a very critical factor for microfrontends with model federation. And to be honest, without shared dependencies, model federation would probably not even be possible. So what are we talking about? Let's look at the case for React. At the moment, all of our microfrontends and the suite itself are built using React. So naively, when we are saying, okay, every solution, every app needs React to run, we have a total of 9 solutions. We need to download it every time. So basically, we download it with the suite, and then we download it again when we are starting AdFarm, and so on. At the end, you would download React up to 9 times. Well, that's kind of stupid. Why do we need to download React over and over again when it's already there? Because the suite has loaded it already. And this is exactly what shared dependencies now is. Because the answer is, well, just don't. Under the hood, it basically works that we have when we're using shared dependencies, we have this shared dependency space. And model federation is smart enough to know if something is already in this shared dependency space, it doesn't need to be re-downloaded again. Basically, you can let the other applications just use it from this shared space. And that's exactly what's happening here with React. So rather than re-downloading it 9 times, we just use the one in the suite that is already there, basically. Which is kind of obvious that how this saves loading time, I guess, because all these shared dependencies, we only downloaded once instead of 9 times, which is already great itself. However, there's also a technical reason why we sometimes need to share something. So it's not only dependent loading times. Let's look at first the context where we don't at a place where we don't share it. So if we have 2 applications running here, both with their own instance of React. Both, of course, can initiate a context on their own. However, this instance B of React has no chance to ever access context A from the other instance, or vice versa. And sometimes you need that. Sometimes you need to have some shared context, shared states that you can access from different solutions. And simply by, instead of initiating a new context, initiating a new instance of React, but using the same one in all the applications or solutions, you can now have shared contexts, which is really necessary at some cases. For us in Yara Plus, particularly, there are 3 external dependencies where we have that. By the way, because I will mention this later, we're calling this the singleton requirement for these cases where we have to share it, where we have this technical requirement to have a single instance running. For us, the external dependencies are React, because we depend on having a couple of shared contexts that each of our applications need to access. We're sharing React Router, because by sharing React Router, we have a single history and navigation state, which makes navigating across the boundaries of the individual solutions much easier. For example, like just go back to the previous page, which was in another solution, is possible through stuff like this very easily. And the last thing we have to share from the external dependency is our authentication context. This is at least our way how we achieving having one user session spanning all of our individual solutions, rather than needing, let's say, don't need to log in AdFarm again if you're already logged in the entire Yara Plus context. So far I covered that by sharing dependencies we can save loading times, and sometimes we need to share it for technical reasons. However, as everything, there's nothing free in life. And in the for shared dependencies, the cost is a coupling of the microfrontends of all the solutions. Because if you share something as a singleton particularly, all of your solutions are bound to use exactly the same version, or not actually even same instance, but at the end it boils down to the version. Now, if there's a breaking change in this version, you need to upgrade all your microfrontends at exactly the same time. And here we are kind of like breaking the idea of the microphones in some way, because now all of a sudden we need to deploy all of our now 9 solutions at the exactly same time, just to avoid one of them crashing, because that is what would happen if there's one of them is not ready for this breaking change that we are just like in a dependency. And this is kind of like a little bit painful for us, or at least it took us a while to actually also get a hang on this. And we realized now basically 2 things we're usually looking at to consider should we share something or not. The first one is, do we need to technically? So do we have like the singleton requirement or not? And the second one that we are typically evaluating is the stability of the dependency. So are there a lot of breaking changes or not? So if we are landing in the bottom right, so where we have an unstable API, so a lot of breaking changes, but we don't have a technical requirement to share it, the easy answer is, yeah, we simply don't. An example for us is our UI library, where tended, particularly at the beginning, to be rather unstable, and we didn't want to have that unnecessary coordination here every time just someone changed something in the button. And the consistency here wasn't that critical for us in this. Like, at least for a couple of weeks, we could live with slightly modifications here. If we're moving up, so we have, again, like no technical requirement, but a stable dependency. This is where we are really seriously considering it. Because particularly when there is the dependency is large, we really can save a lot by, like a lot of loading time by sharing it. And this is, at the end, the user is going to like it, because the app's going to be more responsive. Like, as soon as you open AdFarm, you don't need to wait for very long. It shows up as faster. People are going to enjoy it much more browsing around in this page, or explore different solutions also. And because it's a stable dependency, we don't have a lot of coordination to do anyway. Now, when we're moving on the left in this graph, things look different because here we have the singleton requirement. So we actually don't really have a chance to but share it. However, it really depends if you're on the top or on the bottom. In the top, because it's stable, it's all good usually to do it. Like for us, React Router, we're sharing them. We don't really need to think about it much. I think the last time I really remember that something happened was something in React Router was breaking stuff that was more than a year ago. So usually we don't really talk about it much, so not a big issue here. However, if we're in the bottom, where we have an unstable dependency that we must share, this is really our danger zone. Because when you're landing down there with a lot of breaking changes, you have to coordinate a lot, just as I mentioned. And you're really getting this feeling of having a distributed monolith, which means you're having the worst things of the monolith, which is like the coupling and the coordination and no independency between the solutions. However, you also have the additional complexity of the microfrontend setup. So this is what we are trying to avoid. However, we ended up accidentally also creating one our own at some point. So let me tell you how we ended up into there. So in this poly-repro approach that we're having, so where each microfrontend is in its own GitHub repository, we still need to share some code between them. And for this, like some custom libraries are kind of a critical aspect of the setup. And for our React package or React applications, the most commonly used library then is Yara React. And we have a singleton requirement for this one because there's stuff like our user access, our custom routing logic that we're having built on top of React Router, application setup. These need to be consistent throughout all our solutions. So we need to share it. However, organically, like over time, this application grew, like this library grew and grew. More stuff was added. At some point, we had a bunch of utilities there. Then even the definitions of our breakpoints. Later, UI components and even some styling stuff. It was kind of like getting quite out of hand, and I already grouped them in here by stability. So the stuff on the left, usually we didn't touch it so much. We initially had a work to do there, but once it was up and running, we were fine. However, particularly with the UI components, oftentimes there was something changing, and it was like kind of painful because that means every time someone changed something in this UI components, we had to release a new version and upgrade it at the same time, all microfrontends, meaning we needed to coordinate a lot. It meant like opening a lot of PRs, getting them all approved, pressing merge at the same time just to avoid some application crashing somehow. It was really painful. Basically, every sprint we were talking about this kind of stuff. After looking at it for a while, our solution kind of now looking back is obvious, but took us a while to actually understand this. We have to split this library. So basically, really like split it in the middle, keep the stuff that we had to share, like with the singleton requirement in Yara React, which of course then had to remain shared. However, since these were the stable things, it wasn't a big deal to share that for us. We don't have a lot of issues here. And then the unstable part moved to its new library because the biggest part of UI components, we named it React UI for us internally. And this one we don't share anymore. So every application can now upgrade it in their own time. We don't need to coordinate this. The inconsistencies that might live for maybe 2 weeks is definitely not worth the additional coordination effort. And this definitely went down because now we're talking about it like maybe every couple of months still, which is a huge improvement. However, this was also not the only challenge that we've been facing for microfrontends. For the next one, I will hand over to Theo.
Thank you, Konstantin. Now, let's take a look at another challenge which we are facing, which is client-side cache management. So why do we care about the cache at all? Well, if done right, caching can vastly improve user experience. You reduce the loading size of these pages. You speed up the pages. You reduce unnecessary network loads, which also your mobile users will thank you for. And you can also allow for offline functionality. A stale cache, however, showing old data can not only confuse your users, but also can scare them away from using your app, which is the last thing you want to do. And of course, you're right. Caching is not solely a problem for micro frontends, but having multiple micro frontends really amplifies this problem a lot, which we're going to see in a moment. So Boyan mentioned we're using GraphQL, and there's one thing to notice. If you're using regular REST APIs, you can leverage the HTTP caching mechanisms of your browser. So because each URL is unique, as per definition, you go to /posts, for example, your browser will be able to cache every subsequent request from the server and manage it on its own. GraphQL doesn't have this possibility because you only have the /GraphQL endpoint, so you cannot build a HTTP cache based on this. Luckily, there's a solution for this, and it's called Apollo Client. So Apollo Client is a GraphQL state management library for TypeScript. It's the counterpart of Apollo, which we use in the backend. And it basically restores all of your results for your queries and your mutations in its own cache, which you then can access. So it might look like something like this. You have a field in the cache, so this is our agronomical fields. It is identified by its type name and its ID. As a combination of both. And you can see multiple fields in the cache itself. So for example, a field might have a name, a field might have a size, and it has a boundary, and many more attributes. So when using Apollo in micro frontends, you have two choices. Either you build a distributed cache, which means each micro frontend uses its own Apollo instance and its own cache, or you build a shared cache, which is what we did. And the reason being is all of our solutions share the same backend and all of the same entities. So we have fields which are identical, we have fertilizers which are all the same, organizations, etc. So by having one cache, we only have one single source of truth, which makes it way easier to synchronize the cache between the apps and the suite, instead of having to manually copy some of the cache state from one micro frontend to the other one. The neat thing is it lives inside the suite, and we can also persist it in the local storage of the browser. So you have it across multiple sessions. And yeah, basically the idea is that you only have to keep one cache in sync instead of multiple ones. So let's look at a real-world example. Users in our application are able to modify a field boundary. So you might create a field, and later you decide that your field does not match what you actually have in real life. So you basically change how it looks like. At the beginning, we have a rectangle, and then you just simply drag and draw everything. And then at the end, you have a field which is way smaller, but it's a triangle now. So let's take a look behind the scenes. What could be going wrong here? So we have one micro frontend, which fires a query to get the field details. It's called get field details in this case, but every micro frontend is free to call it what they want. We just want to get one single field, which is ID 4 here in this case, and we are only interested in the ID, name, geometry, and area. As Boyan pointed out, that's the neat thing of GraphQL. You don't have to request everything, just the things you're interested in. So what happens is we fire the query against the server queries it from the database, sends the response back, Apollo caches it. Nice. So in this case here, you notice I have just put a square for geometry because you've seen the field was a square. In reality, it's a little bit more complex, and it's a GeoJSON, but that will do for now. This, however, does not solve all our problems, because you see, we might have a different micro frontend who now wants to update a field. It wants to update exactly the same field. So it says, hey, this field is now called field B, and its geometry should be a triangle instead. However, this front end is only interested in its ID, name, and geometry. It doesn't display the size of the field, so it doesn't need to load it from the server. What now happens is we do the request, we get the response, and we update only the fields that we requested, because these were the ones that the server delivered to us. So right now we have a state where we have ID, name, and geometry fresh from the server, but notice that the area is still in green from the last request, which means now we have stale data here, which is something we want to really avoid, because we do recommendations based on field size. So you can imagine that we recommend you to put certain amounts of fertilizer on your field, and when you have a bigger field, we recommend you to put more of it on a field. However, if now the area is calculated wrongly from a stale cache, you could do irreversible damage to your field, which is really what we want to avoid, because then I guess you'll no longer be our customer. Okay, there's certain things how we can solve this, right? So there's built in Apollo is a refetch queries argument, which means every time you do a mutation, you can give it a list of queries that it should be refetching. So this is very neat. However, you have to name exactly the queries that you want to refetch. This is nice in a single setup, but with our multiple front ends, we don't know how the other front ends called the query, so we cannot fetch them. If you should be aware of something like where we can do pattern matching or something for this, please come talk to us after the talk. We would be really interested because we didn't figure it out. So we had to resort to a different option, which is updating the cache by hand, which also works, but it's really tedious. So every time you get a response, you update the cache, you just manipulate it directly. And in this case, you need to duplicate all the business logic. You have to recalculate all the field area again, and yeah, that's just a hassle you don't want to do for every field. The last thing you can do, which we still do on some pages and which is valid advice, is bypassing the cache on critical pages. But this is a little bit like salt in a soup. You want to not overdo it. If you do it all the time, you just basically get rid of your cache, and then you're not having the benefits of caching in the first place anymore. And then when we are looking for another solution, it suddenly makes click and realized our problem is not really of technical nature, but it's of conceptual nature. So our problem is we don't know what the other microfrontends query. We don't know what they want, and we also don't know how other fields might be related to each other. So with geometry and area, it's quite clear how they are related. Every one of you would have figured this out, but there might be more hidden cases that are more difficult to track. So we had a different idea, which is we're using subscriptions, which are native to GraphQL. So we basically have a real-time communication between the client and the server, and we move the problem into the backend. So our backend knows how the entities are related to each other. So the idea is basically we just let the backend decide when an entity needs to be invalidated and then send its ID to the front end. And the front end just executes it centrally, invalidates the cache entry, and then because the cache is shared, it's for all micro front ends, it's invalidated. And the next time you want to access a field, you see that it's invalidated and you get the response from the server instead, which solves all our problems here. So again, Konstantin mentioned we have multiple challenges, and we have one more for you, which is organizational complexity. So we decided to really have a lot of microservices, micro front ends, so we have a lot of stuff that we have to care for. And one thing that makes it easier for us is that we have TypeScript across all our code base, so all our backends, all our front ends use TypeScript. We use the exact same tooling. We have ESLint, we have Prettier, we have Yarn. So when you drop one developer into another project, into another repository, he will be able to find its way rather easy. We also use a design system to ensure consistency, so you don't have to build every UI component yourself. You can just take a look at Ahua and grab from them, and then you're golden most of the time. We also have a collection of custom libraries, mostly helper functions and other stuff, also CI/CD workflows that we completely share. And we basically release them with semantic versioning. So we know when there's a breaking change, and every micro frontend is aware that there's a breaking change, so it doesn't have to consume them directly. Of course, this also requires that we communicate between the teams, because we have to know that there's a breaking change. And this, I cannot stress enough, if you do everything split, communication is really the key. So we have some weekly meetings of team leads to just discuss what's coming up next, which with changes we are going to tackle. We have dedicated Teams channels where we keep up to date and just announce the changes. And basically, we also have regular internal workshops just to keep up to date. Pretty usual stuff. Okay. So maybe to sum it up for you, we've seen Yara Plus as a digital farming solution. And we realized Yara Plus caters really, really diverse farming needs. We have a lot of things we need to do. And we decided to go all in micro. We have micro frontends, micro backends. And the message here is basically splitting things can work if you can draw clear boundaries. If you cannot draw them, then it becomes really tedious. The thing is, we all work in agile environments, or at least most of us do. And there, things change, business requirements change. And then you're in the situation where you have to decide if you want to split a service, if you want to combine a few services, or what you have to do in these situations is really not as easy and straightforward. Again, you will need good communication, no way around it. If you don't communicate, you will fail, period. And although we advise, right, divide and conquer, there's still a thing that the cake doesn't get smaller just because you cut more pieces out of it. You still have a lot of work to do. We still have business requirements that we have to fulfill. And yeah. In the end, we haven't found the holy grail. We don't claim to, and that's totally fine. We've been doing this now for 3 years. We're still learning. We're still growing. We're still making mistakes, but that's fine in the end. Should you have any questions, don't hesitate to ask them.
Yes, thank you very much. Thank you very much for this nice talk, three of you. And as Theo already hinted at, are there any questions in the room? Yes. If you're loud enough, you can shout it.
There are remote people also, maybe.
Oh, no, I just got I have to give the mic. Sorry.
Thanks for the great talk. A question regarding the communication and the deployment. You mentioned that you have dependencies between the micro front ends, and yeah, it's kind of fine. But how do you make sure that you deploy at the same time? Like, it still leads to issues like customer could have some of the micro front ends still cached in the browser while others are not cached and loaded fresh. So isn't there an issue that they would need different contexts?
So, okay. So the way how we communicate, so we kind of have like established some release process that we're kind of coordinating. So there's like different stages, like on the development stage, like whatever we are pushing on the main branch, automatically going to deploy. And then we are manually triggering basically our releases to the integration and production environments. And for this one, we are kind of usually coordinating just to make sure everyone is kind of ready for these changes, and there's also some testing before. Of course, like as you mentioned, there's this chance that the micro frontend is still cached. I think, like at least to my knowledge, there's nothing we can really do about this then. I remember like we had some cases where that happened. I'm not sure like if this really happened also on production environments or just on testing environments. I usually got pinged by QA about this on development environment, and that was usually solving itself after a couple of refreshes or maybe half an hour. But maybe there's a good strategy. I would be super interested to how to avoid it completely, but nothing I can think of right now, at least.
All right, any more questions? Yes, I'm getting Miles here.
Yes, maybe a non-technical question about the map you showed in the beginning, how much fertilizer you need for parts of the field. On what data is this based? Is this data gathered by the farmers, or how do you get the information to calculate that?
It's basically we communicate with satellites, there are some sensors, and we get some base information, and then based on the Yara's agronomists, there are some kind of calculations, all the knowledge we are in the end calculating based on the satellite images and sensors. We are calculating what should be the amount that we should apply in each part of the field. So it's basically a combination of the input data, which is the satellites, the sensors, and the knowledge of Yara employees, agronomists.
All right, we would have time for one last question. Yes, please.
So you guys mentioned that you are currently using a custom sort of plugin that is not officially supported. I think nowadays there is one. Are there any advantages to switching actually over to the other one?
Yeah, I guess that's a very interesting question you're raising here right now. I mean, I already mentioned that there's also some pain points in the plugin that we're using right now. I think the first one would be a lack of documentation there, and also that it's kind of like it's following somehow the module federation standards, but it's even to me still today unclear like where they're not following, because it's poorly documented and the code is also, I don't want to say a bit messy, but yeah. I think like the really exciting part right now is that there is this version 2.0 released. And I would be really interested to get my hands on that, actually, because the splitting of this runtime API that I mentioned, this was introduced, really allows you to basically, at runtime, be completely independent of the bundler. So that means like you can do your own kind of like module federation in the, compatible building without needing to rely on how it's loaded, because it's just standardized, like this API, how it's going to be loaded. And I think this would be the most interesting part. I also know that like last year there's like a module federation /Vite plugin for Vite also now. They, ironically, that exists since longer, but only last year they also migrated to use the actual model federation standards properly. I'm also didn't have my hands on it yet, but I would expect maybe they are a bit closer to it. And like one of the pain points is that at least we didn't figure out there's something that is also like you can share dependencies not as a singleton, usually in model federation, which kind of comes with the benefits like you can share the dependency, but you don't need to use the same instance. So let's say in your, let's say in the suite, we are saying like we're needing version 1 and one microfrontend using version 2 already. Or then there's going to be the matching basically in this shared dependency space. There is only version 1 loaded so far. Okay, let me also load version 2 from the bundle of the remote and also put it there for this other application to use. But at least from my understanding, and maybe it's wrong because of poor documentation then also, this is not possible in the current application, current plugin. So that would be one of my main pain points that I would like to solve. And I think like with Model Federation 2.0, that's more available than ever right now.
Short version, we are looking into it.
Thanks.
All right, and with this, I'll leave you to the rest to enjoy the rest of the Big Tech Day. Thank you very much, and give our presenters a last round of applause.